Hello everyone. My talk today is over the edge Pwning the Windows kernel. As you know, the Microsoft, they are improving exploit mitigations day and day. So it's more and more difficult to break out the edge sandbox. In last year, my team had achieved 3 different ways from edge to system. And I'm very glad to share my research with you at the HILB conference. My name is Rancho. I'm a security researcher of Tencent Zhanlu Lab. Tencent surely is a company name. Zhanlu Lab, maybe you have not heard before. But I think some of you know about the King Lab, right? Tencent's King Lab. We belong to a same department. Currently, I'm focused about kernel security and bug hunting. You can find me on Twitter. And this is my Twitter account. About my team. The director of my team is Yuan, one of the most famous hackers in China. Yes, he is. He had achieved a way bypass ASLR and DP without ROP 9 years ago. He did. So he is very famous in China. The Zhanlu Lab and the Tencent King Lab and the Xuanwu Lab, we all belong to Tencent Security Joint Lab. And we are Pwning winner for Edge last year. And we are hiring. Anyone wants a job for security research or just bug hunting, please contact me. This is a Twitter account of my team. The presentation will be divided in 2 parts. First part, I will talk about the Win32K subsystem, how to analyze and how to fuzz. I think some of you already know about the Win32K subsystem, right? But I will introduce several of my unique discoveries. The second part, I will discuss 4 vulnerabilities or 3 exploits I have used. At last, I will show you a demo from Edge get removed system. Win32K is a huge and complex subsystem. Basically, it contains 2 types of objects, the user object and the GDI object. If you are familiar with Win32 program, you will learn about some objects such as window, menu, bitmap, device context from the Microsoft document, right? But as a bug hunter, we need to understand more than the document. A global variable in kernel, it named gshared_info. It contains all the user objects and info. And for user object, the allocation function is allocate object. So we look up the cross-reference of alloc object function. We can find out almost all the types of user object. Similarly, as the user object, a global variable named G.H manager is in kernel. It maintains the hand info of all GDI objects. And the same as the user object, we can look up the reference of allocate object function, and we can get most of the types of GDI objects. This table shows almost all types of user object and GDI objects. For Windows, the B type is 1. For menu, the B type is 2, and so on. Now, how to fast the WinC2K subsystem? The state of the art, sure, it's right. The basic thought of my father is fast the relationship. First, we study the relationship between different objects. And then we find out all the operations with the relationship. And we can do the operations readily. And at the same time, we modify the state of the objects. If you have good luck, you can already get bugs. The table shows several relationships between several objects. For window, you can set parent window. Yeah? And for decomposition, you can remove or replace children. However, if you do this job a little longer, you may feel that it's getting harder to find available vulnerabilities. Obviously, so many people have fuzzed the WinC2K already. Yeah? And some of them are still fuzzing. So, we need some different point of views, or we must find some unique attack vectors. So, dig in a little deeper. If you have diff the syscall table between NT4 version and NT2000, you will find some syscalls disappeared from the table. Where are these functions now? Microsoft had moved them to a function table. It's named GAPFN message call. In fact, we can call these functions directly by passing different XPFN proc parameters. The same, you can find another function table, APFN simple call. We can also call these functions directly by passing different XPFN proc parameters. So, my father will go fuzzing deeper, right? Another attack surface You know about it. It's first discussed publicly at 2011 7 years ago. The Windows kernel enabled a mechanism from kernel mode callback user functions. Obviously, this mechanism is easy to lead synchrony issues. But so many years passed. Microsoft has patched it many times. Can we still get something from this attack vector? I think we can. Let's review the Win2k. There's still many references of k user mode callback function in Win2k. Now, how to find bug? By code auditing? I think it's difficult to get bugs by code auditing because 7 years passed. Many people already audited this code, right? So I choose fuzzy. In a PAB structure, a field named kernel callback table, it points to a function array, the user mode callback functions. We can hook some of these functions and build more complex further. Let me show you. This is a sample code of my father. When my father initialized, I hook several functions of the user callback table and set them jump into a common entry, the client callback function. And we need to pay attention to avoid re-entry this function. I do fast link this entry once again. This method will make our father, the execution path of our father could be very complicated. Yeah. So this method can really find bugs. But it's a big problem. Because of the hooks, the crash stack will be untrackable. I have to spend a lot of time for guessing and analysis to reproduce these issues. And I don't have a perfect idea for reproduce matter. But it works. But you can find bugs. Another attack vector, maybe no one had mentioned before my talk. The public object. When I observe the GDI object handle info in kernel, I notice that some objects have a zero owner PID. It means the object is a public owned object. In fact, the object with a zero owner PID usually is created by Win2k driver itself. The kernel maps the GDI handle info table to user space. In the PEB structure, the GDI shared handle table, this field, Win32k no longer discloses the kernel address of GDI objects, but we can still get valid info from this table, such as the hand value and the owner PID and the type of the object. So we can search public owned objects from user space. This is a sample for search public owned palette. For palette, its object type equals to 8. And I search the GDI table. I search the GDI info table. And when I found the object, its owner PID is 0, I add this object to my fuzzing list. By fuzzing the publicly owned object, I got some unique bugs. Yeah. The second part, how to escape from the H sandbox. First, I give you a short briefing about the H syscall filter. As the picture shows, the Win32k filter blocked most of Win32k syscalls from the H content process. As this picture, Microsoft had implemented 6 different tables as service table filter. A syscall should be blocked or not according to the filter table. Now, the Win32k filter greatly reduced the attack surface from kernel. So, it's a huge challenge for breaking the H sandbox. I will introduce 3 ways over the H. First, analyze the object operation functions from the unfiltered syscall list. And we can fuzz these few objects. Second, abuse a bug in Chakra engine to bypass Win32k filter. It's an interesting bug. Third, fuzz the DirectX graphic kernel driver and get available vulnerabilities. The CVE 2017-8465 is a cursor user-free. It's a very good vulnerability discovered by Liang of Tencent Security, of Tencent PC Manager. Liang is a good partner of my team. We can review the proof of context code, context first. As you see, all the functions we need for triggering the bug is not blocked before June last year. And we had used this bug bypassed H sandbox in Pwning. The root case of this bug, the specific flaw exists within the link cursor function. When a user unlink a cursor from the dpi link list, a user free exists. Now let's study this case. For a cursor object, it has 2 pointers, the head point and the next point. If you linked 2 cursors together, they will form a double linked list, as you see. So, the first step, we created 2 cursors and linked them. The second step, we can reset the cursor 2. Cursor 2, its head point to itself. Step 3, we destroy cursor 2 and the next pointer of cursor 1. It points a freed cursor. Yeah. So now the next point of cursor 1 is a dangling point. Next, when we destroy cursor 1, the kernel will go on to free the cursor 2 once again. Right? So it's a double free. For use free, we must know which part of the freed object could be used, could be reused. For this case, we used the next point of cursor 1. We reclaim the freed cursor 2 with the accelerated table object. And we construct the fake cursor 2 data, make its next point to a controllable memory. When we destroy cursor 1, a function hm mark object destroy will modify a bit of arbitrary address we specified. Now, let's put it together. The exploitation steps is as follows. First, we link 2 cursors and then destroy the cursor 2. Second, we spray accelerator table objects to reclaim the freed cursor object. Third step, we trigger this vulnerability, and we can modify a palette object, and we abuse palette primitives to gain full access of kernel address. This bug is patched on June last year. The Microsoft create empty cursor functions from APFN simple core table. So you cannot create an empty cursor. And a user can no longer link 2 cursors at all. a checker bug for bypass WinC2K filter. It's a very good bug. The analysis is based on Redstone 3 versions before September of 2017 year. Review the code of PS's WinC2K filter enabled function. You will find a mitigation flag named Enable Filtered WinC2K APIs. What's about it? From the Windows 10 inside preview versions 15048, as I remember, the Edge browser enabled out of process JIT server. The JIT server is introduced as a mitigation against abusing JavaScript JIT code bypass CFG, but it also introduced a good bug. For the JIT server process, we found that the WinC2K filter is not enabled. Did you see? It's 0. So, if we can execute arbitrary code in the JIT process, we can bypass the WinC2K filter. When I observe the handle info of a Edge content process, as the image shows, the JIT process PID 6464. I noticed that an Edge content process owns a process handler. As you see, DUP handler. The process explorer failed to decode all the handler info. But what's this? Why these handlers had DUP handler permission? Let's review the chakra code. We read the code of JIT client, and we found that this handler is used for communication with the JIT server process. And it can be used to duplicate a full access process handler from the JIT server. So, it's a very good bug. The proof of context code as follows. We just duplicate a handler of JIT process, and we have full access permission to JIT server. We just inject shared code to the JIT process. Abusing this bug, we can bypass WinC2K filter from Edge content process, and we can exploit a WinC2K bug without restriction now. WinC2K bug. CVE 2017-8580. It's a pilot use FE. It's a good case I found. And it's about public GDI object. Let's review the root cause of this vulnerability. This function, eng delete pilot, is designed for printer driver and the display driver. You notice that it passed a shared lock equals to 2 to the unref palette function. When the kernel invoking EPAL obj constructor, it auto-lock once. So eng delete palette function could be used to free a palette with non-zero shared count. First, we created a palette. Surely, the share count is 0, right? And we select it to a device context. But I found its share count is still 0. What's wrong? Actually, the device context did not reference a palette directly. It referenced with a surface in kernel, and the surface could reference a palette. So if we created a device-independent bitmap with this device context, the kernel will create a public palette, copy color data from the palette we previously created. This public owned palette, its share count is 1. Now, we can search the GDI handle table in user space and find out the handle value of this public palette. Finally, we can delete this palette. And it's what we get now. A device context has a point referenced to a bitmap in kernel, and a surface point referenced to a freed palette. So let's reuse the freed palette. When you review the code of GRE set DIB color table function, you can find that the copy RGB quart function will copy data from user memory to the color table of palette object. The exploitation steps as follows. First, we trigger the vulnerability and allocate server meta file objects to reclaim memory. And then we call the set DIB color table, and we can get an arbitrary address right. Abusing the bug with the checker duplicate handle issue, now we can escape from sandbox. The palette use are free patched on July last year. Microsoft just fixed the share count passed from eng delete palette. And the duplicate handle issue of checker engine, collided by Ivan Frederick of Project Zero, The patch day of September last year, I was very upset because I have 3 good checker bugs been patched in one day. And now the checker JIT process enabled the filter flag. So maybe there's no filter bypass anymore. Yesterday, at this conference, track 4, 2 researchers from Microsoft, they have a talk, the life and the death of kernel object abuse. Death. They used a terrible word, but probably it's true for WinC2K. From the Windows 10 Redstone 4, Microsoft introduced type isolation for WinC2K. This mechanism separates the metadata from the head of a GDI object, and it truly killed the popular exploitation techniques such as bitmap primitives and palette primitives. So, for breaking sandbox, the way from WinC2K is very hard. What shall we do now? It's time to turn our attention to another subsystem, DirectX subsystem. It can be considered as an extension of WinC2K. Many of the DirectX kernel functions are still not filtered. Maybe there's no much time to talk about how to fuzz the DirectX kernel. So let's review our exploit first. The CV 2018-0977, discovered by my father. When a user submits a command to DirectX kernel driver, the driver will notify system process, start a worker thread to execute the command. An untrust point reference exits in basic render. If we construct a special command and submit, we will trigger a crash. And we can control the RDI register and the RAX register. And for guard dispatch, I call no function. In fact, there's no check for RAX register. So, no kernel CFG for this case. So we are going to rope. But it's not easy for rope, because the crash is occurred in system process. For system process, there's no user memory, right? And we must lay out data in kernel. How should we do? And for a system process, there is no WinC2K objects, neither. Because the WinC2K objects, their insertion pool is not mapped to system process. So, I used an anti-kernel objects named pipe to lay out data in kernel. When I began to rope, I set RSP register point to the pipe name. Yeah. A named pipe, it contains a point to a wide string. Obviously, we need an info leak because we need NT-kernel base to calculate gadgets address. And we need the pipe name's address. I found a very good kernel info leak, but it's still unpatched, so I will not discuss this issue in this speech. Anyway, we had an info leak already, and let's go on the exploitation. I have found some gadgets. As you see, we can control the RAX register by an instruction of KSE get IO callbacks function, right? And then we can set the value of RCX register. And finally, we got arbitrary address right arbitrary value. For kernel exploit, it's okay. So it's a demo. First, we got a code execution by a JIT bug in checker engine. How to start? Oh, yeah. Sorry. Very fast, right? This issue is patched in last month. Once again, collected by somebody. On the announcement page of this bug, Microsoft made a mistake. It's not a Win32k bug, I think. It's a DirectX elevation of privilege vulnerability. Thanks to my colleagues, Yuange and Chenan, most of my research is owned to them. And thanks Yin Liang of PC Manager. He's a kind man and he's a good partner. And thanks to Henry Lee of my lab. He provided the chakra exploit, which you just saw. At last, thanks to Peter of KinLab. He had did nice job about kernel exploit before me. This is the reference. Anyone has questions?
So we are going to open the questions on the floor. Anyone have any questions want to ask? Yes? No? The man is
Okay.
So the DirectX bug you showed here, is that the one used in Pwning 2018?
The cursor use are free. Yeah, the cursor use are free. We used in last year.
So because in 2018 there was a Firefox sandbox was bypassed using a claimed Win32k kernel exploit, and I heard it was the same vulnerability that you showed here, the DirectX vulnerability. So do I understand correctly that Win32k lockdown would not have prevented this?
Sorry,
So the Win32k lockdown would not have prevented the DirectX vulnerability. Is that correct?
Sorry, 翻译一下。该怎么说？ For Firefox, it's not blocked from WinC2K.
Yes, we know. The question was,
For
our
sorry.
question basically was, if we would have blocked it, would it have helped? Because we are not blocking it right now. We are having a lot of trouble.
If
with
you
this.
blocked the WinC2K syscalls, right?
Yes.
If you block it, I think it cannot. The WinC2K bar will be unavailable for sandbox. Yeah.
Okay, thanks.
More questions? If you guys can meet him personally to ask more questions, I will be a translator for you guys. Right, thank you.